June 1944. Somewhere in rural France. A German supply convoy rolls through the night, headlights dimmed against Allied air patrols. The lead truck hits something on the road, a small metallic object no bigger than a man's fist. The tyre bursts, then the second truck, then the third. Within minutes, the entire convoy sits stranded on a country road in resistance territory, bleeding air from shredded rubber. The drivers find the culprit scattered across the asphalt, twisted pieces of metal, each with 4 sharpened spikes arranged so that one point always faces upward. Medieval technology, delivered by the British, and it was paralysing German logistics across occupied France. The device was called a caltrop. British engineers at the Special Operations Executive had taken a weapon design older than gunpowder and mass-produced it for modern sabotage. Each one cost pennies to manufacture. Thousands could fit in a single supply canister, and according to French regional archives, resistance fighters spread them across every major road network in northern France during the summer of 1944. The Germans called the sabotage campaign a plague. SOE called it Plan Tortue, Plan Tortoise, because it would slow the enemy to a crawl. Germany's problem in occupied France was distance. When the Allies landed in Normandy, German reinforcements had to travel hundreds of kilometres by road and rail to reach the beachhead. The Wehrmacht relied on truck convoys to move troops, ammunition, fuel and supplies. Every kilometre of French road represented a vulnerability. The resistance knew this. SOE knew this. The question was how to exploit it with limited resources and untrained civilians. Traditional sabotage required explosives, timing devices and technical expertise. Railway lines could be cut with charges, but bridges were guarded and tracks could be repaired within hours. SOE needed something simpler, something that any farmer or shopkeeper could deploy without training, something that could be scattered across a road in seconds and retrieved just as quickly if a German patrol approached. The solution came from military history books. Roman legions had used caltrops against cavalry. Medieval armies scattered them to slow advancing infantry. Now British engineers would use them against pneumatic tyres. Station 9 at the Froith Mansion near Welwyn Garden City served as SOE's primary research and development facility. The site was officially designated on the 19th of July, 1940. Lieutenant Colonel John Dolphin commanded the station, with Professor D.M. Newitt leading scientific research. Their mandate was to create equipment light enough for parachute drops, strong enough to survive landing, simple enough for untrained operatives, and impossible to trace back to Britain. The caltrop met every requirement. According to Imperial War Museum records, the standard SOE 4-point caltrop measured 59 mm by 59 mm by 51 mm. Solid metal construction with tetrahedral geometry guaranteed that one spike always pointed upward regardless of how the device landed. The American Office of Strategic Services developed their own version measuring 8.6 centimeters per side, with hollow spikes that allowed air to escape even if the points became blocked by soft ground. Dr. Stanley Lovell, director of OSS Research and Development, called it the simplest weapon we ever made. SOE also developed more sophisticated tyre sabotage tools. The coin-type tyre slasher, now held in the Imperial War Museum collection, measured 58 mm by 37 mm by 5 mm with its blade extended. Constructed as a steel disc with a knurled edge, it concealed a short curved blade deployed by a lever. The device could pass casual inspection by resembling a large coin. One example was issued to Wing Commander F.F.E. Yo Thomas, the famous White Rabbit, before his missions into occupied France. A second variant, the Daggerjack DB clasp knife, measured 122 mm closed and featured a claw-shaped tyre slasher blade at the pommel. Both designs were manufactured sterile, meaning they carried no markings that could identify their country of origin. Station 12 at Aston House near Stevenage handled production and distribution. Colonel Leslie J. Cardew Wood commanded the facility, which one historian described as a strong contender for the original Q from the Bond novels. By late 1942, 2 or 3 lorries departed daily carrying SOE equipment for dispatch to occupied Europe. Production records show over 12 million time-delay detonators and 38,500 limpet mines manufactured at the facility. Specific production figures for caltrops remain classified or lost, but the devices required minimal materials and could be stamped out by any metalworking shop. Now, Before we get into how these devices performed in the field, if you're finding this interesting, consider subscribing. It takes a second and helps the channel grow. Back to the sabotage campaign. Supplies reached French resistance networks primarily through parachute drops using CLE canisters. The Mark I container measured 1.7 meters long by 40 centimeters in diameter, with approximately 159 kilograms capacity. RAF Tempsford served as the primary departure airfield. Halifax bombers carried 15 containers per sortie. Stirling Mark IV aircraft managed 20. Total supplies delivered to France reached 10,000 tons of equipment, 4,000 before the invasion and 6,000 after. By June 1944, 50 wireless links connected London to French resistance movements. Plan Tortue activated on the 5th and 6th of June 1944, triggered by coded BBC personal messages including the "Phrase will fetch show a Suez, it is hot in Suez." French regional archives from the Aisne department record that numerous tyre puncture devices were spread on the main roads of the department. Resistance did not fail to sew special nails on the roads. Sector 146 near St. Quentin documented fighters spreading caltrops and removing road signs to disorient German convoys throughout July and August. The most famous example of transport sabotage affecting German operations was the delay imposed on the 2nd SS Panzer Division Das Reich. The division was stationed near Montauban in southern France when the invasion began. The journey to Normandy should have taken 3 days. It took 17. SOE's own after-action report stated that the extra fortnight's delay imposed on what should have been a 3-day journey may well have been of decisive importance for the successful securing of the Normandy bridgehead. However, historical accuracy requires acknowledging that railway sabotage, not caltrops, caused most of that delay. Tony Brooks's Pimento circuit sabotaged railway flat cars by draining axle oil and replacing it with abrasive powder delivered by SOE. Additional delays came from felled trees blocking roads, ambushes by Marquis units, and Royal Air Force strikes on fuel trains directed by Special Air Service teams. The Imperial War Museum catalogue itself notes that the coin-type tyre slasher blade must have been of doubtful utility against thick-walled military vehicle tyres. Caltrops worked best against softer civilian tyres, pressed into military service, staff cars, and requisitioned trucks rather than purpose-built military transport. German countermeasures included convoy escorts, route inspections, and brutal reprisals against civilian populations. General Otto von Stülpnagel announced in September 1940 that no mercy would be granted to saboteurs and all saboteurs would be shot. The Das Reich Division's passage through the Limousin region, which Germans called Little Russia due to resistance intensity, resulted in the Oradour-sur-Glane massacre on the 10th of June 1944, where 642 civilians were killed, and the Tula hangings on the 9th of June, where 99 civilians were executed. Field Marshal Wilhelm Keitel acknowledged that acts of sabotage became horrifying, frequent in France, and even in Belgium. General Eisenhower's Supreme Headquarters, Allied Expeditionary Force, credited resistance operations with imposing more or less serious delays on all the divisions moved to Normandy. The strategic value was not measured in individual tyres punctured, but in cumulative friction, the military term for all the small delays and complications that slow an army's response time. Every stranded convoy meant troops arriving late, ammunition running short, and commanders making decisions without complete forces available. The caltrop represented something essential about British, unconventional warfare philosophy. While Germany invested in Tiger tanks and V-2 rockets, Britain invested in cheap, mass-produced sabotage tools that turned occupied populations into force multipliers. A single SOE canister could contain enough caltrops to close a road for hours. 100 canisters could paralyse an entire region's transport network. The cost ratio favoured the British by orders of magnitude. MRD Foote, the official SOE historian with privileged access to surviving records, later noted that the organisation revived some medieval devices, such as the caltrop, which could be used to burst the tyres of vehicles or injure foot soldiers. The technology was ancient, the application was modern, and the results, though impossible to quantify precisely, contributed to the broader campaign that kept German reinforcements from reaching Normandy at full strength during the critical first weeks of the invasion. British engineers did not invent the caltrop. They did something more characteristic of British military innovation. They recognised an old solution to a new problem, manufactured it efficiently, and distributed it to the people who needed it most. The device cost almost nothing, it required no training to use, it could not be traced. And scattered across the roads of occupied France in the summer of 1944, it helped ensure that German convoys moved at the speed Britain chose, not the speed Germany needed.